Hello everyone. We are the authors of Intelligent Grimm, open-ended visual storytelling via latent diffusion models from Shanghai Jiaotong University. Today, we would like to give a brief introduction of our paper. As we know, existing storytelling works are limited to a few animations, covering a closed set of vocabulary or characters, suffering from severe overfitting on scene characters. For example, many works focus on Flintstone's SV dataset, which only has 7 different characters. In this work, we focus on a novel, yet challenging task of generating consistent and coherent storybooks based on any given storylines, characters, and artistic styles, denoted as open-ended visual storytelling. In this work, we make the following 3 contributions. First, we propose the task of generating a sequence of images that tell a visually coherent story, denoted as open-ended visual storytelling. Second, to fulfill the task of visual storytelling, we propose a learning-based autoregressive image generation model, termed as StoryGen, with a novel vision language context module that enables to generate the current frame by conditioning on the corresponding text prompt and preceding image caption pairs. Third, to address the data shortage of visual storytelling, we collect paired image text sequences by sourcing from online videos and open source ebooks, establishing processing pipeline for constructing a large-scale dataset with diverse characters, storylines, and artistic styles, named Story Salon. We introduce a learning-based model for open-ended visual storytelling, termed as StoryGen, which means that the model can directly generalize to unseen characters without any further optimization. Specifically, to achieve consistency within the generated image sequence, we incorporate an additional image cross-attention layer parallel to the original text cross-attention layer into the pre-trained Stable Diffusion model, which provides visual context by conditioning the generation process on extracted diffusion denoising feature of previous frames under the guidance of corresponding captions. Therefore, the generation is conditioned on the text prompt and multiple previous image text pairs. As we have mentioned, previous closed-set datasets with limited characters and styles are insufficient for generalization towards open-set storytelling. Specifically, we extract keyframes from a large number of storytelling videos and open-source ebooks, and align the keyframes with corresponding subtitles, both store-level narration and descriptive captions. Compared with previous datasets with less than 10 characters, our dataset comprises hundreds of character categories and even more character instances, which provides a databasis for training open-ended visual storytelling models. We compare our StoryGen model with other baselines on Story Salon test set using subjective human evaluation and quantitative metrics. Our StoryGen model exhibits significant performance improvement in terms of FID score and clip-I similarity compared to existing models, while maintaining comparable clip-T similarity. The results of human evaluation also illustrate that our StoryGen model demonstrates excellent performance in overall score, especially in terms of consistency and quality. In ablation studies, we demonstrate the effectiveness of our proposed modules. Here are qualitative comparison with other methods. The image sequences in orange, green, and blue boxes are generated by Prompt SDM, ARLDM, and StoryGen respectively. Our synthesis results exhibit impressive performance superiority in terms of style, content and character consistency, text-image alignment, and image quality. We provide more results of story generation. Our StoryGen shows superior performance compared with SDM, Prompt SDM, and single-frame StoryGen, and achieve distinct character consistency. In story continuation, our StoryGen still significantly outperforms StoryDoll and ARLDM. We hope to more intuitively demonstrate that our proposed context module can accurately capture the image content of the previous frame. To this end, we incorporate our context module into SDM and train it from scratch on the Mskoko with other parameters frozen. As shown in the figure above, our model can make full use of the objects in the reference frame and generate new images that are consistent with them, while SDM fails to do so, which strongly illustrates the robustness and capability of our context module to assist diffusion models in generating images based on any given object. For limitations, our StoryGen inevitably inherits some shortcomings of pre-trained Stable Diffusion, such as difficulties in generating particularly complex scenes and characters. Our StoryGen has demonstrated the ability of multi-character storytelling, and we aim to achieve a more aggressive goal of consistent video generation with multi-characters. We also release our dataset on Hugging Face and code on GitHub. That's all. Thanks for your attention.